Okay, so we're going to finish up 2-2 today, right?
Yep.
Okay. So this derivative rule puts a constant in front. It's the same rule. We have a c. So you just take the c times the derivative. So you had x to the n. So the derivative of x to the n, I don't know, that's bad. Can't write it like that. We had d dx of x to the n was n x to the n minus 1. Yes? So now we have a constant in front, so you just multiply the n by the constant. That's it. So we have y equals 2 over x. So we need to rewrite this. A lot of rewriting today. So it would be the derivative of 2 times x to the negative 1. Why did I go negative 1?
Because you have to get the x up top.
Right, gotta get the x up top. You don't know the quotient rule yet. Okay, so now, according to this rule, we do it the same, but we just multiply the 2. So f prime of x equals 2 times negative 1 x to the negative 2.
So you just move the...
So it'd be negative 2 over x squared. Essentially what you were doing yesterday, but the coefficient of all your x's or whatever variables was 1.
So can you do that one again?
So the negative 1 came out front. So 2 times negative 1. And negative 1 minus 1 is negative 2.
Why did you get the negative 2 in the back?
Because 1 minus 1.
Oh, yeah. Okay, never mind.
Okay, so now I have f of t equals 4t squared over 5. Well, we want to get the constant away, so we're going to take the derivative of 4/5 t squared. Do you see how just rewriting that a little bit helps you look at it differently?
Yeah.
So the derivative then would be 4/5 times 2. And you minus 1 from the 2. So t to the first. So you get 8/5 t. So y equals 2 the square root of x. What do I need to do to the square root of x? What power is that? 1/2. So I have 2x to the 1/2. Why did I put inverse over here? You guys did not call me out on that.
Where?
Over there I put to the negative 1. I think I even said inverse. Okay, so 2 times 1/2 is... I'm going to minus 1, so negative 1/2. So 2 times 1/2 is 1. So that gives me 1 over x to the 1/2. Can I leave a rational number in the denominator? No. So I got an x to the 1/2 and x to the 1/2. So that gives me the square root of x over x. Now I'm going back and forth between square roots and fractional exponents, back and forth with not saying much. That's where you guys need to be. Okay?
So on some of them, when it, like, because I know some of them, if it's in the bottom, we have to move it to the top, then it turns negative. Why couldn't we do it to that one?
Well, because you don't want negative exponents ever in a final answer. And then you don't want irrational numbers in denominators. Now I'm going to tell you on the computer, I don't know if they're picky like that. So you'll just have to see. Like if you move everything around and they're like, no, that doesn't work, put it back to your like this answer and see what it says. Definitely no negative exponents, okay? Okay, so find the derivative. So I just given you more stuff that looks like stuff, right? So we need to rewrite them. And a lot of times in the textbook we'll say rewrite, find the derivative. Rewrite, find the derivative. And it's like making you do the steps that I'm telling you have to do anyway. So how could I write 1 over 2 cube root of x squared? How could I rewrite that? What's the constant up there?
2.
Well, where's 2?
In the front.
Isn't it 1/2? 1/2's the constant, right? Okay. And I want that cube root of x squared up in the numerator. So it's going to have a what exponent?
Negative.
Negative. And what is that exponent going to be? Because I don't want it the cube root anymore.
-6.
Power goes up on top. So what's its power? What's its power?
-2.
Power is 2. And the root is
3.
3. So 1/3 was right, but you need to have its power. And before the power, it didn't have any power written, so the power was automatically just 1. Does that make sense?
Mm-hmm.
Okay. So you want to try this one on your own?
No.
No? You're no fun. Okay, so f prime of x, or the derivative. So I'm going to have 1/2 times negative 2/3. And x to the, well, if I minus 1, so that'd be minus 3 over 3, correct? So it'd be negative what?
5/3.
Okay, so negative 5/3. So 2's reduced over here. So I get negative 1/3. And x to the negative 5/3. Well, the 3 goes in the bottom, yes?
Yeah.
So I have a negative, and the 3 goes in the bottom. This x to the 5/3 is going to go in the bottom. But can we leave an irrational number in the bottom? No. So what do I need to add to it to get to the next whole number? 1/3. So I do x to the 1/3 and x to the 1/3. So that gives me negative the cube root of x over 3x to the what?
2.
Because 1 plus 5 is 6, divided by 3 is 2. Can you put the cube root in the computer, Jaden? Can you put the cube root in as an answer?
Yeah. What do you mean? What?
Like, can you type the cube root in? Does it give you formatting?
Yes.
Okay, any root? Like it has a root where you can put it in there? Okay. Because if that ever goes away, then you would have to leave it x to the 1/3. Okay, well, after that one, the next one looks really easy, doesn't it?
Yeah.
How are we going to rewrite it?
-3/2 x.
Yep, negative 3/2 x. Well, after doing any sort of derivative yesterday, the derivative of x is just what? 1, right? Because you bring out a 1 and you subtract 1 and you get 0. So my answer is just so really any different than you did yesterday? No. Do you have to rewrite things?
Yes.
Yes. And that's the key, rewriting.
Okay.
Constant multiplier and power rule can be combined into one rule to do combinations of things. These, okay, if you look at them, what do you see the difference between these problems? Parentheses, right. So like this one, if you guys want to do them, we will, but my main thing, I want to rewrite them. Does that make sense?
Yeah.
Okay, so this one would be 5/2 x to the negative 3. Okay. Well, what do
we just take the numbers and put them over each other, then the x?
and that one, yeah, because there's no parenthesis. Okay. So the next one, there's a parenthesis. I have to deal with that, don't I?
Yeah.
So it'd be 2 cubed. So it'd be 5/8 x to the negative 3. Okay. Well, this one seems silly. What would it be?
7 over
7/3.
3. And then x to the negative 2.
Or just x squared, wouldn't it? Because if it's negative in the denominator, you bring it up, it'd be positive.
Yeah. But your other ones are negative.
What other ones?
The first and second one. Or do you have to make them negative since they were?
Well, we had to make them negative to bring them up to the numerator. Because we don't know how to deal with anything in the denominator yet. Okay. Now what do I do with the next one?
It'll be 7 over 14. No, 7 over 9.
But it's to the negative 2, so it needs to go where? Up.
21.
9 times 7.
9 times 7. Not 3 times 7 no more.
Because it's squared, right? So it'd be 63 x squared.
That's dumb.
That is really dumb.
So it's just because it's negative?
Mm-hmm.
Like
If it's negative
that
in the denominator, it has to go to the
top.
numerator. If it's
So then you have to multiply that, like the...
well, you have to distribute it because it's
squared
both.
times
Yeah, because they're
the
both.
7.
No, it's not on the 7. It's only
But-
on the
On that one with the 5, we just put it 5 over 8 because the 2...
right, but it wasn't negative.
Yeah, so I'm saying on the
Oh,
last one, if
I'm
it's
sorry.
negative, then you times it by the 7.
Yes, the 9. Yes,
The 9, because you got the 9 from the 3 squared.
yes. Ainsley, question?
No,
No, you do have a question. What is it?
makes no sense.
Okay, right here, this negative exponent has to be. So I have 7 over 3 to the negative 2 and x to the negative 2. Correct? Okay, so in order to get rid of a negative exponent, you bring it to the numerator. So that gives me 7 times 9 times x squared, which should be 63x squared. Now, looking at any of these problems, would you struggle with finding the derivative of any of them?
All of them.
Okay, well then we better do them.
No, that's okay.
No,
I'll struggle on my own.
no.
I think I'm just going to get confused on, like, changing it like we did, but... Yeah, get those parentheses out of here. Yeah, get those parentheses out of here.
Well, the reason they're there is I wanted you to see what they did. And is rewriting them one of the most important steps?
Yes.
Yes. Until you get the chain rule and the quotient rule and the product rule, you don't know how to deal with those things. So it's important that we get the basic rule down and be able to work with our exponents and negative exponents and fractional exponents.
There should be exponents.
No, your world is exponents now.
No.
Is there one of these four that you guys would like to do?
Do the second one. Yeah.
Okay. So it would be 5/8 times what?
3.
How about -3?
-3.
And it would be x to the...
-3. Oh, -2. -4.
So my answer then would be -15/8. -15/8 x to the 4th. Why did the x to the 4th come back to the denominator? Because it's negative. And we don't leave negative exponents.
Don't touch me. Well, I don't like this anymore. I never liked it from the start.
It was easy yesterday.
It's still easy. It's all a frame of mind. Okay, so all this says is if I have something that looks like this, I can take the derivative of one and add it to the derivative of other. That's it. That's all it says.
Okay.
So if I have this and I want the derivative of it, I'm going to take the derivative of this minus the derivative of this plus the derivative of that. That's it.
You knew that already.
But you haven't done it. You've just done one thing. So what's the derivative of x cubed?
3x squared.
So 3x squared. What's the derivative of -4x?
No, I don't know.
Well, it'd be -4 times 1
It'd be
x
-4.
to the 1 minus 1. So it'd just be,
-4.
and what's the derivative of any constant?
0.
0. So there's your answer.
Yeah, I can do that.
So 0?
No, it's 3x squared minus
Oh.
4.
Okay.
Okay, what do you notice about this and this?
They're the 0 ones.
They
It's
both
like-
have a 3.
It's like when you
No, they
do
don't.
division and it goes down one.
It goes down by
I
1.
thought you were talking about the whole thing.
Okay, why is it going down by 1 degree?
Because we did short division.
No, because we did what?
Followed the rule.
We subtracted 1.
Yeah.
So this equation, the top equation,
Where did the 5 go?
the derivative of any constant is 0. So it went to 0. So the first equation, the graph looks like something like this, yes?
Sure.
The second equation, the graph looks something like that.
Parabola.
Okay, so we want the instantaneous rate of change, and if we're graphing change, anytime you have a max or a min would be my new zeros. So my new graph would look something like
Okay.
so if I had, well, you got to think about what's going on.
Well,
Okay, so what if I had this?
that was a good line.
She used the...
I used the line
cheated.
thing. Okay, what did I say? Anytime you have a max or min, it becomes a what of the derivative?
0.
So you bring it here,
And there. And
there,
And
there. And when if you go from odd, the next one would be even, yes?
yes.
If it ends up there, it's going to end up
There.
there. See how you could sketch a graph of anything? Of its derivative as long as you had it?
Yeah, but are we going to have to sketch graphs?
Yep.
On the computer? No, we don't. It gives the graphs for us.
But you will have to On a test, you're going to have to sketch it. That was really easy.
No. Don't make a sketch, no graphs.
Okay, I want you guys to do the derivative of the next one all on your own.
Oh, okay. We can do the easy one together.
That's not... How do you rewrite this? How do you rewrite?
2.
No.
Negative 2. Negative
No.
4x
No.
to the third over
No.
0.
Negative 1/2 x to the
Oh.
fourth.
Four.
Now do the derivative.
Okay.
You can't take it out of the denominator if it doesn't have a negative exponent.
I can do whatever I want because all these rules are just made up.
Yeah, they really are.
Okay,
Who-
do the problem.
who
People
decided?
are going to listen to you. I'm going to send this out in the world and they
Oh,
can
you're
listen to you.
actually recording?
Yes, I'm recording.
Okay, what am I doing wrong on this third one?
Find
Like,
the instantaneous velocity of t is 2 and 3. So you found the derivative. You got it right.
Yeah.
Okay, so you're putting it in negative 32 times 2.
How do I?
So it'd be
How
negative
do I
64.
rewrite 3x to the third?
And then you have it times 3, which would be 696.
It's
I put it in at 16 that time,
Oh.
and not 32.
like what
Well,
if
I don't
you
know.
That makes more
square
sense
now?
Yes. No.
Well, it's 3
It wouldn't be
times
3. It'd be 3 times 3, which would be
9.
9.
Well, I don't even know how to do the 1/2 x to the
Minus
4th.
2. Done.
Wait, why is it
I'm
a 3 next? The other one we did 1.
What?
Why is it a 3 squared? Or 3 cubed? Or,
This is the original problem right here.
yeah.
Minus 2.
Okay? So,
The other one for 4, we did 1.
right.
Why is that one a 3?
It's not. She was asking about the middle term.
That's what I'm saying.
The answer to it is negative 2x cubed plus 9x squared minus 2. That's the answer. Okay. What did you think this was 3?
No, the middle one. Where does the 3 come in to make
Okay.
it 9?
Because it's 3 times 3, x 3 minus 1. This 3 has to be multiplied. Because the rule is constant x to the n is the constant times n x to the n minus 1.
I understand it. I can
I also
do it
understand.
now. I think.
Okay, Riley,
Well-
why couldn't you take half of 4?
What do you mean?
You said, well, I don't know what to do with it. You have 4 times a half.
Well, I could. I just
Didn't want to because it's a fraction. Guys, fractions.
No, fractions do not scare me.
Okay, good.
I just didn't want to do it.
I'll make a haunted house and it's all going to be full of fractions and factoring.
Probably the worst haunted house I ever set my foot into.
Any bath farmhouse.
Okay,
Any bath house? Not walking into. This is Calc was on the door and I'm crying and peeing myself.
okay,
Oh, get those out of here.
sine and cosine.
I can't.
Okay, you need these rules. You need them written in your notes. Write them down. Okay. Ainsley, were you finished with the slide? I thought you were
Yes.
done. Okay. So, these are just what they are. The derivative of sine is cosine. It is. That's what it is. The derivative of cosine is negative sine. It just is. You guys will make a derivative sheet. In your notes, you need to go back and highlight these rules. So when I tell you to start making your derivative sheet, you know what to put on them.
Derivative sheet.
Yes. You will have a
Is it on our
derivative
test-
sheet.
Or our test?
Not for a long time. And then you will have an integral sheet. You will
We're not
have,
gonna use on our test either.
not for a long time. It will be a complete notebook piece of paper when we're done. But I will also tell you, if you do all your practice, by the time you're done, you won't need your sheet for much. The trig ones are probably one you'll have to, but you have to know those two. Okay?
Sine is cosine. Cosine is negative sine.
Yes. Okay, so I have y equals 2 sine of x.
2 cosine
So
x.
the y prime equals 2 times, and then the derivative of sine is
Cosine x.
cosine.
Okay, now that actually equals 2 negative sine x.
No, what do I do with the 2? What do I do with the 2?
Get it up there.
1/2.
Yeah. And then it's 1/2 cosine x.
Okay, or I could just write it as cosine x over 2, but I don't. I think that's gross. I will probably never write anything like that.
And then you have x.
So the same rule applies here. We take the derivative of x, and we take the derivative of cosine. So the derivative of x, there's a 1, a 1, a 1. The derivative of x is 1. And then the derivative of cosine is,
Minus sine x.
so minus sine of x. And every year I get somebody going, but why? Because y is the rule.
But why what?
Y is the derivative of cosine negative sine. It's because that's the rule I gave you.
Well, then can you just keep going?
Yes.
1 minus cosine and 1 plus sine again. And then
Yes,
1
because we will do things like that. That means take the derivative of the derivative, yes?
Yeah.
So what's the derivative of 1?
1
Nope.
minus
0.
0.
minus cosine.
And
now
we could
that's-
do it
Now we're at
Derivative of the derivative of
The
one
derivative.
sine again.
so be back to, because it'd be negative sign, right?
You just go forever, have a little ring around the rosy session.
Okay, but that only applies to here. What happens to my numbers? I eventually get to what?
0.
0, not numbers, like variables. If I have variables, I will eventually get to 0. So I was at the first, I could do the first derivative, but the second derivative gave me a 0. So if I was at the fifth,
It's gonna take you a while.
how many times would I have to do it?
5, 4.
Well, I was at 1, and it took me 2 to get to 0.
3, then 2,
So I'm at 5, it's going to take me to
6.
6. The sixth derivative would be 0.
Who's there? Not here.
Okay,
I'll stab you.
no stabbing, please stop. Stop. Okay, now velocity function. Right now, you just need to know we have it. It's a position function. You use it in physics a lot. They're used a lot in physics problems. There's calc-based physics where you have to make all your functions. So the position function is the change of s, which is considered the position variable, equals s times t plus the change of t minus s of t. Well, what is change of t? Change of what? Change of what? What's t? What's t?
H.
What is t?
Time.
Time.
Oh.
Delta is the change. Delta, and then what is t? T is time. And yes, it is the h. Yes, it is. It is all that. But t is time. That's what I was trying to get out of you. Okay. More familiar formula you should know is rate equals distance over time. Correct. Okay. And we have average velocity, which is the change of distance over the change of time, which is change of s over change of t, which is basically just slope. Yes? Think about it. T would be your h, so s would be your k. So average velocity, average rate of change. So those are formulas that obviously the change of position would not be something that would be in your memory banks, but rate and average velocity could be associated with slope, which is already there. Again, highlighters on notes would be a great thing, guys. You need to find one color for like derivative rules, and then you need to find other colors, another color for like other things. Does that make sense? You need one color for derivative rules.
Where's our cool pencil?
Oh, I have it over here.
What?
Oh, just a second. Just a second.
I'm taking notes right now.
So with this, we can find a position of something at any time. And gravity is negative 32 feet per second. Is that right? Physics, have you been doing gravity yet? No. Ainsley's. Tell me when you're good there, Cadence.
I'm good.
Okay, it says find the average velocity of a falling object. It gives me my position function right here. Okay, average velocity. So we have to find the two velocities and find the slope. Yes?
Yep.
Yes? So at these times, so these are t, and I have to find an s. So when t is 1, what's s?
100.
Probably not.
2.
That would be, when t is 1, it'd be 100 minus 16, which would be
84.
84.
Yeah, that's what I said.
Yeah. And when t is 2, 2 squared is 4, 4 times 16, 64. Yes? Because 4 cubed, 64.
Yep. Yes.
So 100 minus 64.
Four cubed is 16.
No, 2 squared is, okay, but 2 squared is 4. I was thinking of it this way, probably confused you. 2 squared is 4. 4 times 16 is 64.
You were saying 4 squared is 64.
I said 4 cubed is 64 because 4 squared is 16. I was thinking it backwards. Okay, so 100 minus 64.
Good question. 36.
Thank you. Okay, well, 1 minus 2 is 1, right? So you have 36 minus 84 over 2 minus 1.
Yep.
So it'd be negative,
32.
no. 14 minus 6 would be 8.
It'd be 48.
Over 1, so it's 48 feet per seconds.
Sure.
What does it say?
No.
Height,
Yes. Feet
Yep.
and seconds.
seconds, right here. Okay, do I need to keep doing these?
No.
Yes. Please keep doing them.
Okay, so when it wants the average velocity, it's the average rate of change, it is the what?
Speed.
Slope,
Yep.
okay. Why is it negative? Because the object is what? Falling.
And because it's 36 minus 84, which is gonna be
Actually,
negative.
it's actually falling, so
Velocity shows direction.
thank you.
Okay, what time are we?
Math homework time.
Okay. Velocity function is the derivative of the position function. So this is important. Velocity is the derivative of the position function. So if I give you a position function, its velocity is its derivative. What was the variable for position? S. The variable for velocity is?
T.
How about V? T is time. Do not worry about this. All this is derivative, yes? So don't worry about writing that down. Velocity can be positive, negative, or zero. The speed of an object is an absolute value of velocity. Okay, can speed be negative?
No.
No. Speed cannot be negative, but can velocity be negative? Yes. So speed equals the absolute value of the velocity. That's what that statement says. And we used speed, we used S for position function. Let me put speed.
Are you kidding me, Riley?
Okay. Position of a free falling object negating air resistance under the influence of gravity. Neglecting, not negating, but same word, same meaning. Thank you. Okay. We have, I'm going to read this formula to you. You have the position at time. You too. Focus, please. Is 1/2, what does G stand for?
Gravity.
Gravity, but acceleration of gravity. And what's T? Time. V sub 0 is the velocity at 0, initial velocity. Velocity at 0 time. And S sub 0 is the height or the position at 0 time. Most of these will be made for you, but it's really not that hard to do. On Earth, gravity is negative 32 feet per second squared, or negative 9.8 meters per second. That is a fact that you should know. It's something that you should have as you start doing these problems, because you will have to from time to time write those. So 1/2 G T squared plus V sub 0 plus S sub 0. 1/2 is 1/2. It's always 1/2. It never changes. Got it?
Yep.
Okay. G is gravity, the acceleration due to gravity on Earth. It's negative 32 feet per second squared, or negative 9.8 meters per second squared, depending on where you are at in the world, correct? V sub 0, anything sub 0 means initial. Anything. So velocity at 0 time. If I drop an object, what's my velocity at 0 time?
0.
0. If I throw it, does it have a velocity? Yes. If I shoot it out of a cannon, does it have a velocity?
Yes.
Yes. But if I just drop it, does it have a velocity?
No.
No. Okay. S sub 0 is its height at initial. When I'm on the ground, it's what? 0. If I'm up in the air, it's however tall the building is. Got it?
Yep.
Okay. I want to click through these. Yep, I only have one more slide. That's it. So, here's the diver. Just, do they give me the position function?
Yes.
Yes, they do. This is its height at initial time, yes?
Yep.
Isn't that also a y-intercept? Yes.
Yep.
Okay, so it asked me for when does the diver hit the ground or hit the water? Well, the water would be what position? 0. So it wants to know how long it's going to take, right?
Yep.
So this is 0, yes?
Mm-hmm.
So 0 equals negative 16t squared plus 16t plus 32. So if I want to know where it's equal 0, I probably better do what with that problem?
Factor it.
Factor it.
Take out 16 or negative.
Yes, to factor out a negative 16, definitely, right? So t squared,
plus t
how about minus t?
minus t minus 2.
Okay, factors of 2 that have a difference of 1. 2 and
2 and 1.
positive 1. So So T would equal -1 and 2. Okay, what does T stand for again? Time. Can time be negative? No. So when does this diver hit the water?
2.
At 2 what?
I don't know. Seconds.
Seconds. Okay, it has 2 answers. Does it have 2 good answers?
There's only one good answer.
Because this equation is a parabola, yes?
What if they were both good answers then? Like it was 1 and 2.
It's not gonna happen. It would have to be something weird. Like it's a trampoline or something.
Pretty wacky.
Okay, remember when we started talking about parabolas in Algebra 2? We talked about everything that is kicked, thrown, jumps off, whatever. It looks like a what? Parabola? Why do you think a position function is a parabola? Okay, the next one, guys, it says the velocity at impact. How do I find velocity? I find the what of this function?
Height.
The derivative of the position equals velocity. So that'd be -32t plus 16. That would be the derivative. And then it says, what is the diver's velocity at impact? Well, impact was what seconds?
2 seconds.
2 seconds. So I plug in
2.
2. So that'd be -64 plus 16, which would be 8, 5, 48, -48 feet per second squared. It's a little fast, isn't it?
That's pretty fast.
Is that why it hurts if you don't